Hello everyone, thanks for coming to my presentation. There's a lot of great choices, so I appreciate you. If I wasn't here, I'd be somewhere else, so I appreciate that you made this choice. So who am I and what are we talking about here? I'm from Eharmony.com, but I'm actually talking about an incubated site that we've launched called Jazz.com that's built on top of Solr. In fact, it's kind of built around Solr. Who am I? I've been doing web apps for a while. I've been a part of search for a long time. During the keynote, when they were going through the presentations, I worked for Disney at the InfoSeek acquisition, so I know a little bit about UltraSeek. I used to use the Alta Vista. I've pretty much used most of the kind of web crawlers. I had some LUCENE experience earlier incarnations of Eharmony. Solr, this has been working on it for about 2 years for the Jazz product. What is Jazz? Jazz is kind of a direct competitor with, say, Match.com or OkCupid or what we call in the space photo personal sites. I won't get into too much detail about what Eharmony is, but I do always have to ask. There's enough people in here. Has anybody found the love of their life on Eharmony? It's a gamble. Sometimes it pays off. Maybe somebody did and just aren't admitting it. So Jazz is a new incubated site for us. It's really targeted towards a wide spectrum as opposed to Eharmony, which is about serious matchmaking, finding long-term compatibility with people. Jazz is more user-focused. You build searches, and we help find relevant profiles. So what can you do? You create a profile. You use it to search for other people. You look at their photos. You communicate with them. So what makes it different? It's a broad range of relationships. It's whatever you're looking for. Again, not so relationship-minded. It's really low barrier to entry. I think this is a huge differentiator for us that's not Solr, is that we do a really good job screening profiles to get rid of all the fake profiles. I don't know if there's anybody, I won't make people raise their hands if they've used online personals because a lot of people get really sensitive to that. But when you go look at a lot of sites, there becomes this really fun game of called, yep, that's a fake one, yep, that's a fake one, fake, fake, fake. So we do a lot of machine learning as well as human review to make sure our profiles are real people. We decided that we were going to build this whole thing around Solr. Why? Because we looked at the search technology that other people were using in the space, and it just was not, it was substandard, or at least what they were doing with it was substandard. So just to give a few stats on the Jazz product itself, it's very new, it's very incubated. So we're not talking huge volumes at this point. We do this right. Hopefully next time I present, it'll be a large-scale big data problem that I'm presenting about, but we're not quite there yet. How do we build this? As an incubator, it's also a technology incubator for us, so we're using kind of next-generation architecture in our mind to build it as a proving ground for that, and take the pieces we find successful and bring them back into the core enterprise architecture. Typical kind of Java, modern Java tech stack. Solr 1.4.1. Love to be on the new version, but not quite there yet. No surprises here. So this is kind of the logical diagram of the entire site. We're really going to just focus on the Solr-backed services, primarily what we call our profile service, which is kind of the core business service of the application. The disclaimer of what I'm not going to talk about, because there are a lot of people that are going to be talking about this stuff. We don't have a big data problem, so we don't have distributed searching problems yet. We don't have caching problems yet. Our data is being imported by questionnaire, so we don't have to use any of Tika or any of the fancy data importing stuff. It's all great. I just don't know much about it because it's not our problem space. And not surprisingly, when you're searching for people, it's not so much a full text problem. So I'm not going to dive into a lot of analyzers and tokenizers. And it's also not an internationalized site at this time, so I don't have any comment on that. I'll actually have questions for other people in here as well as the conference when it's time for that. So why do we pick LUCENE? As the Lucid guys always say, LUCENE is not a search library. It's an information retrieval library, and finding people is effectively an information retrieval problem. We embrace the NoSQL philosophy at Eharmony. We have databases. We also have more than databases, so we're very open to storing data in all kinds of solutions. The most compelling thing I think for the Jazz perspective was flexible ranking models. We know quite a bit about ranking at Eharmony. It's a problem that we have throughout the entire enterprise. But it was just interesting to think about looking at the competitors and whether Redheads or Blue Eyes was all very Boolean. It was all very, very predictable how they were coming back. We thought, wouldn't it be much better if we could make this a ranking problem? So why Solr? Because if you're going to start off now, why start with LUCENE when you can start with a service wrapper that lets you use all of its features plus more? Especially, and this is so much better now, but I mean, a few years ago, before the Solr and LUCENE ecosystems kind of merged, there was stuff in Solr that should have been in LUCENE and vice versa, and they're sorting all that out now, but the Solr query language being a superset of LUCENE's was really, really interesting to us. Having all the operational stuff was really handy for us not to have to worry about. So why do we pick open source at Eharmony? This is an easy one. We think it makes better engineers, and that's one thing we're really concerned about. It's something that my CTO is very focused on. Allows us to talk about problems that aren't our core intellectual property in an open environment that help and leverage other people's strengths. It's guaranteed not to be brochureware. So many open source, in fact, a lot of open source projects have the opposite problem. There's no brochure at all. I mean, I think there's a nice balance with the Solr LUCENE community. So why do we embrace this NoSQL beyond the buzzwordiness of it? Is we have a lot of different problems. They can be solved in different ways. An Oracle solution or any kind of traditional relational database system is not going to solve all of them. It's going to solve some of them very, very well. It's going to solve other ones okay, and then other ones it's not going to do a very good job. We've generally switched to the prefer horizontal scaling over vertical approach. So to dive a little deep, to get away from kind of this operational stuff, why do we care about ranking? The tools like Solr allow us to do a hybrid approach. What we discovered from a business perspective as we kind of started fleshing out, Jazzed is lots of people can think in kind of SQL type terms, including business people, whether they can embrace it using the terminology or not, they think that way. So when you start talking about ranking or fuzzy matching, as they like to, or at least my business people always talk about fuzzy matching. So, well, it's not that fuzzy. It's give a score and sort by score. But they start to get a little scared because they don't understand the exact ordering. When I think the first requirements that came in was on the sorting was this very complicated nested sort of all these different values. And when we started talking about ranking, we're like, well, you can't sort on that anymore. You're sorting on kind of the score. And what having Solr in there has allowed us to have various strategies, various hybrids. We've had pure Boolean stuff that we probably could have done just as easily in a database, but we've always had the full text stuff. But as we build our own kind of functions to boost and amend scoring, the function support is really nice. So many other things, right? Standard plugins built in. Now geospatial is. It wasn't at the time that we were using it, but faceting, which we're not doing right now, but we're really interested in. Spelling is an interesting thing for a personal site. What we've found is that people don't like when other people misspell. And so using a spelling component is really helpful for us to understand how and when to present a profile to another person. Full text is nice. We don't find a lot of people using the full text component of our site, but it is very fast when it happens. I was thinking about this morning during the keynote. A lot of the concerns kind of in the entire space of how do you take a little keyword search like that and make it Google friendly? How do you do some NLP on it? I think there's a lot of room for expansion in that area. We are Java shop through and through, but we want to use things that it doesn't matter how we're talking to them. So there are two inevitable questions that seem to be at every presentation about something, and I know this is an intro to Solr, but I just always want to get these questions out of the way. One, I'm not going to answer because I have never understood this question, and that is it enterprise ready? I still don't, to this day, understand what enterprise ready is. I understand enterprise, I think, but I'm not sure what that means. And does it scale? It's like, well, I can't answer that because from my data. Because my benchmarks that I'm putting up here that I did as a proof of concept are the most load I've still yet to put on Solr, because it is an incubated project. The amazing thing to me is usually when you roll out an open source project, it's usually tuned for some trivial usage. Not to pick on them, but ActiveMQ is this way. You could not roll in any production with ActiveMQ with the settings that come out of the box. But what I found with Solr is you can. Actually, I didn't actually have to start touching the tuning until I'd added 5 million profiles. I was seeding these profile data from existing Eharmony users just to build fake Jazz profiles. The benchmarks are just that. They're just benchmarks. Take them with a huge grain of salt. The random queries I was looking at were kind of what we expected the queries to look like, having anywhere from 5 to 12 terms. It scaled very nicely. So to drill into this profile service itself, it's what we call a hybrid data service in our world. We put data services in front of kind of all data stores. In the case of something like this, we have two back there. We have Solr. We also have Project VOLDEMORT. For those that aren't familiar with that, it's a distributed key value store that came out of the SNA group at LinkedIn. It's like a Cassandra or React or Redis. It's one of the older ones. We made that choice a few years ago. We won't talk really much more about that other than really for this service, VOLDEMORT is the system of record, but it's only be fetchable by key in VOLDEMORT, and then Solr is the system of inquiry. So all queries go through Solr for that. Solr is actually pretty fast at by key access, but we were already using VOLDEMORT to store data that was not, that we didn't care about from a search or sorting perspective, so it was already there, so we might as well make it the system of record. So what's a profile in this terminology we use? It's mostly structured data. People don't actually type all that much about themselves, especially as I talk to all these people, they're dealing with all kinds of text documents, and they're talking about, just gigs and gigs of text. It's like, I don't have that problem because people don't sit down and write gigs and gigs of text about themselves unless they're on Facebook. So it's categorical data or enumerated data as we kind of call it internally. Anyone from kind of trivial ones like eye color to ones that are very important, such as ethnicity or religion. It's really important to specific users. We have lots of type data, birth dates, other dates, numbers, coordinates. We have some text as well. I like to think of that we're inverting people when we put them into Solr. So this is more of a slide for people that don't understand how LUCENE is doing stuff. LUCENE is not indexing a document and then telling you all the terms in it. It's indexing the terms and telling you which documents it's in. This is really an interesting thing, and a tip that I meant to put in as a slide is if you have structured data like gender or hair color, and you're mixing that in the same index with full text terms, you may want to consider namespacing your specific metadata terms so that they don't mix it, so that the statistics about them don't mix in. That, for example, somebody saying red describing their car, you may not want that to mix in with people that are also categorizing themselves as redheads. So for those that aren't coming really from, in our shop at least, it was a lot of people that were coming from a traditional database design and how do we model the similar data in Solr. And so for those people, I always kind of took this approach. It's one table. It's one table that fields can be multi-valued, so you can collapse one-to-many relationships down. It's one table, so if it had parent tables in a third normalized scheme, those are now just columns in that table. And sometimes you want to aggregate fields into composite fields. The example that ships with Solr with the text field where it's copy to from all these different fields to roll up all text is one thing. In my opinion, on smaller projects like this, space is effectively free, so we tried all kinds of different indexes, and once we start running out of disk space, we'll circle back on that. But we, as a new shop, didn't know how we were going to exactly query this, so we kind of over-indexed. And over-indexing in Solr is probably a better idea than over-indexing in, say, a traditional database, at least what I found. So, we went through field by field, deciding if we need to store it or not. If we wanted to display it or sort by it, we wanted to store it. Obviously, if we wanted to search on it, we decided to index it. A lot of categories we have are what we call the desires fields. This is like what ethnicities do you desire, what hair colors do you desire, et cetera. And those are all multi-valued fields. we also created our own type for those. We created a type called enum that is kind of a small text type that all it did was do case-insensitive searching and made sure we used the right tokenizer so that we could separate the namespace by underscores and not have that tokenized as separate tokens. We may find more uses for it later, but adding types into Solr is really easy. So there's the enum type I talked about. We use the tree types. Are there any like Solr 3.1 people here? Okay, so they're the really lucky ones because the T types are on by default now. So anybody here used like LUCENE, say 5 years ago? Okay, the thing that was non-compelling about LUCENE, so 5 years ago, you would use LUCENE in addition to a database because you did all your full text searching in LUCENE and you did all your other searching in a database. And one of the reasons why was range queries. To do a range query in LUCENE back then, this is no longer true, it would actually expand your query. So if you said, I want to find something where between 1 and 100, it would expand that query to 1 or 2 or 3 all the way up to 100. So you got really familiar with query term limit exceeded exception back then, and it wasn't that impressively fast. The other thing is the types were all in lexicographical order, so you would have to do additional sorting anyway. And these guys have since then created these T types. The T is for tree, and some people say try, but I'm here to set the record straight. It is tree, because it's short for retrieval. So unless you say retrieval, wherever you're from, these T types are non-human readable strings, which if you go into the admin of Solr, at least Solr 1.4, and do a histogram on them, you'll quickly understand you probably shouldn't be doing that because it's also barely printable string. That organizes it in type order by significant bits, and the more, it indexes multiple terms for each member of the range, so that it makes range queries really, really fast, like as in MySQL level fast. Once this kind of was innovated, it was more compelling to think about Solr for all of your querying instead of the old model of just full text. Another handy tip is always stick a random field in because we'll get into this later about how to measure. They have a random type that's by default in Solr. It's really nice for you to have one field called random that if you want to sort by random, because if you think you have the killer ranking right now, show that on your A test, sort by random on your B test and see who wins. Because if your killer ranking can't beat random, then it's not killer. Any kind of NoSQL solution, including stuff like Solr, you have to think about data duplication and not be afraid of data duplication. These are the three kind of categories that we found that we need to duplicate data. One is the number of photos is how many photos a user has available right now. Has photos is whether or not they have approved primary photo. So we have a number and a Boolean. We were going to sort by has photos as part of the sort. What we found is we couldn't do functions in the sorting in Solr 1.4. You can now in Solr 3.1, so another reason to upgrade. We'll get into the relationships later, but we represent certain relationships, both sides, by putting the same value in two fields or similar values in two fields. And then how you want to analyze something. We have this aggregate text field that we throw everything into that's got the full kind of text type, but name type is not that. It's like text strict in our case, I believe, so that it's much easier to find names. Saving documents, Solr, for those that don't know, there are no partial updates. It's really fast because it's an in-memory operation, unless you call commit after every save. So if you turn this over to a SQL developer and have them write an implementation, they'll be calling commit after every save. It's a really bad idea. It's writing a new index segment every time you do that. You put that into production, and suddenly you are running out of index writers. So we use autocommit. By default, it's like 100 documents or 500 milliseconds, I believe. I don't think we actually changed that at this point. So we store the system's records of VOLDEMORT because you need to be able to read your own writes when you're updating your own profile. And since our Solr replication is the standard 60 seconds between the index writer and reader, so we can't rely on the index reader to show you your up-to-date data. Again, Solr is fast enough, I think, in a lot of cases to fetch by ID, but since we already had VOLDEMORT there, well, we might as well make it that many microseconds faster. Besides the range queries that I talked about, lots of query handlers that we don't really use, like Dismax. We do use Boost and Geo. Dismax is great from that kind of Google perspective, and eDismax is looking really promising. In our use case, that would require our users to kind of know how to type structured data or for us to do a lot of NLP on it. We may look at that in the future, but for now, we are kind of building a traditional, this field equals this, and this field equals this, and this field equals this. So I think this is the obligatory slide that's going to be in every presentation here about the balance between recall and precision in search terms. Recall and precision is really interesting in a startup where your data is growing as is a function of registration. At first, I think they said this morning about recall is the easiest thing is just to show every document. Yeah, when you first launch a personal site, and you just want to make sure like gender is correct, and then everything else just throw it up there until you get a significant number of people. But yeah, it's people getting a little weirded out about the wrong gender being returned. So just another safety tip if you decide to get in the dating space. There are a few other ones as well. Some of them surprising them, some of them unsurprising. And maybe later over a beer I'll tell you guys about those. So now we've gotten, in some markets especially, we're starting to get enough people that we're focusing on precision and making ranking really a problem. For us, we're still struggling with should we focus that on markets or should we still focus that across the board. That's something that I argue constantly with business people on. The precision problem is where things I think get really interesting. We started with Boolean queries, like I said before. So we set the default operator to and this is, what are we looking for here? A lot of what we're doing also, I think as non-intuitive people is, we have to kind of invert the gender in seeking because we're looking for people looking for you. So we're not, if I'm a man-seeking woman, then I do look for where her gender is female and that she's seeking a male. That's just caused some interesting bugs, people getting their heads around this. So we're looking for blue-eyed, but redheads or blondes. This is where sort order is important because again, it's just a pure Boolean query. So your key business logic is going to be in a sort. This is where it starts to get more interesting, where we're saying, look, the seeking gender is still hard-coded, but the other stuff is kind of fuzzy now. So let's let ranking start coming in to figure out how to order that stuff. So for those that I'm not going to do a 101 on, well, I guess I'll do a brief 101 on the ranking model LUCENE. It's a function of several things. The two kind of big ones are term frequency and IDF. Term frequency is how often a term appears in a document. For you people like searching through emails and stuff, this is really important. The thing that mentions, frequency 7 times is probably more important to your match than the thing that mentions it once. That's not so important on a personal profile. Especially since we don't want the spammers to then just kind of put keywords in. But what is important is IDF. The other kind of key component of ranking these days is the rarer term is more favored of the common. And so if you like red, I got criticized on the title of the slide about, I used to say you should like redheads, but I'm not here to tell you what to like, but here's why you're lucky if you do. Because statistically it's the least common hair color, and at least in our histogram. So if you like that and you're searching for that, those people are going to get boosted up higher because we say, hey, that's pretty relevant. Of course, that's not the only factor involved. The more fields matching, the higher it's ranked. This is the order of that previous query. The people that match both blue-eyed and redheads are going to rank the highest, then blondes, then redheads, then blondes. It's really easy to demonstrate these with only 2 factors, but of course now when we're talking about like our model, which has 30-something factors, the predictability of how it falls out is something just for testing. We're starting to boost things to kind of also circle back to the keynote. We've asked people how important stuff is to them. What we found out is people don't know or aren't necessarily. If you watch what they do versus what they say, those don't always agree. And so our boosting is still going to be a function of both of those. We're still doing research into figuring out how to weight one versus the other. I mean, if somebody says something is a must-have deal breaker, we're going to take that into account. But we're going to still watch if they say deal breaker on, no redheads, and then we see them communicating with redheads. We're going to change that up. A trick that I learned last time at LUCENE Revolution in Boston last year was a thing called filter fields. So we allow you to hide other people's profiles, of course. And so the naive way of doing that is you create a multi-value field. And then you say here, so user 1 is hidden 2, 4, and 6. User 2 doesn't like that, so they also hid user 1. If you want to include this in the query, it's like we're not hidden 2, 4, 6. Needless to say, this is okay in small lists, but for power users that are now starting to hide hundreds or thousands of profiles, which is sort of some people really diligent about that. Again, your query term explosion happens. So instead, what you can do is have the other part of the inverse of the relationship documented, such as it's not who I hid, it's who I've been hidden by. This now makes the query length deterministic because I'm just saying where my ID is not in the hidden by. In fact, what we also do is where we do both. Where in our case, we say where I haven't hidden you and you haven't hidden me. But again, it's only 2 terms instead of an explosion. I got to give a shout out to this for those that don't use it. I love Solr's date math. It is dates in any language. And I've written a few languages now, and there's yet to be one that gets this totally right. I'll give a shout out to the Rails community that their date math enhancements were pretty nice, but this is really good. Can anybody tell me what this query is doing? It's looking for people between 25 and 35 years old. Why is there 36 in there? It's because everyone born 36 years ago after today is still 35. Thank you very much. If you exclude them, they tend to get a little upset. Another good bug, by the way. So we use this distance searching plugin called Solr Local, written by Patrick O'Leary over at AOL. It's helped us out quite a bit. It's really the only choice before Solr 3.1. It was contributed back. It started what has become the geospatial plugin that Steve and other guys wrote. That looks great. Can't wait to get there. But it's the 2 things we've discovered about it is it does add additional overhead to any query, no matter how efficient you're trying to make it. And it does some interesting stuff with memory that you need a lot. You just need to, I believe there's a slow memory leak in it. So we're going to get over to Solr 3.1 as soon as possible, but it's done us right so far. This is something that I encourage everyone to start talking about from day one of your implementation. How do you test the efficiency of your queries? I don't mean efficiency from a performance standpoint. I think everybody has done a lot of people have the performance guru around to pull on that. I'm talking about what we have to do is try different query strategies and see which one works best for our users. Again, the precision versus recall question. So we immediately started naming our different strategies, putting in a little A/B strategy framework so that we could test those out using random, and then have someone that can manage marketing or product people really, really well to keep them focused on trying to measure one thing at a time. They want to multivariate everything. And then they end up sitting around going, so what did we learn? It's just one thing at a time. Another usage that I need to show a little love to is we have a geographic service, which is our system of record for geodata internally. We purchase a lot of postal code data from different countries. We normalize it in here. After moving it into Solr, we get all the distance searching as well as give me, say, all the postal codes within the range of a given postal code. It allows city lookups to be a lot more efficient because now we have full text searching there. It's a very simple service. It is, since it's only updated every few months, there's no reason to have it backed by anything else. Let's get into some operational stuff that we do. Solr's great because we use Jetty. We're a Jetty shop. Tomcat, any servlet container, it'll work. All it needs is access to the file system. I would recommend local file system, shared file systems. You're just asking for trouble. I heard recently somebody talking about that there was still a debate between 32-bit and 64-bit. I'm interested. I didn't realize that was a debate anymore. For Solr, there's really not. You're going to want a lot of memory. It uses memory really well, and so the more you give it, the happier it is. So you're going to need large heaps, unless it's something, well, again, for any non-trivial amount of data. I don't know if this is still valid, the XX use compressed. That's the use compressed pointers, by the way, which compresses down if you're not using, if you're not using 24 gig heap, it's not going to use all 64 bits in the address. It's actually going to compress the pointers down, saving you some memory and also speeding up access compared to the old 64-bit JVMs. In fact, I think it's 88% faster than 32-bit JVM when you use compressed pointers for certain mid-size heaps. I believe this is on by default now in the latest Java 6s. I know it will be on default in Java 7, but if you're not sure, because I'm not sure, then go ahead and use it. We'd love to get on Solr Cloud. We're really excited about it. We don't like single points of failure, and the active passive still constitutes a single point of failure as far as we're concerned, although it's an easy one with failover. We have hardware load balancers. This is a luxury a lot of shops don't have. So we just do load balancing in that so that, say, your update handler is always going to the primary as long as the primary's health check is succeeding. Once it fails, that fails over for us. We've tested it and it works. Luckily, I haven't had to test it in production yet. Should work as well. We just take nightly snapshots. We can't wait to get to kind of zookeeper coordinated ones, not because we need distributed search because of load, but just for the fact that if one fails, the other ones will pick up for it without us losing that much sleep. Another piece of advice, no matter how trivial your app, I would suggest using the multi-core version of Solr. For those that don't know, I'm not talking about cores as in CPUs, but the fact that you can maintain more than one index and hot swap them in and out using some URL commands to Solr is really nice. For backwards compatible changes, it means you could actually swap out your index. You could hot build a new index off the same data and then swap it in when it's ready. That's going to need more coordination than it sounds. It's not as easy as it sounds, but at least the swapping part's very, very. We use it because we have a concept of public profiles as well as private profiles. We search private profiles from our admins and internal users. That's more of your data. Public profiles is, of course, only the data you've wanted to share with other people, and also that we approve, because we don't let you just say anything about yourself before sending it out there. Because, again, people don't really like that. I think everyone still needs to think about security. That query or that document over there actually will delete everything in your index, and it will do it really, really fast. For those that haven't experienced, LUCENE does very quick. It doesn't actually delete when you tell it to delete. It just marks it. It's a soft delete, marks it as soft delete, and it goes away when the index gets rewritten. But that query will delete your entire corpus as fast as you can say oops. This is also, we learned that our ops people were really terrified of that, so they were using the multi-core thing to keep another core around without even kind of, they'd put that in without us kind of knowing, just in case. So what's next for us? Getting over to Solr 3.1, working on different kinds of searches, including some mutual matching ones, as in find me everyone that meets my desired criteria, find me everyone that we both meet each other's desired criteria. Hopefully that's on the roadmap later this year. A problem I think everyone in the space is having, and I mean in the search space, is guided search. How do we get users to search better? How do we get them to find out what they want? And faceting, I think, is a huge part of that. The spelling stuff, we're still trying to figure out how to make this fit right, but there's one school of thought, I'm not going to name names, that thinks we should punish people that write their profiles in cell phone speak. Unless you also wrote your profile in cell phone speak, then you really need to be together. So we're still trying to figure that out, but the spelling components are really interesting to us. Doing kind of categorization, doing some natural language processing, clustering and stuff, and feeding that back into Solr is all in the works for us. I don't have many details because we're still just at the ideation stage on a lot of that. We're doing some research in some of it as well. Hierarchies are really interesting that you can do poor hierarchies. in Solr without anything, as in, if I wanted to say, differentiate between people that watch football and people that play football, I could index that as like active/football and passive/football. And then the tokenizer would split that into the two terms, active and football, so that if you then wanted to search for one of those, it would differentiate them. Building taxonomies and hierarchies is not easy, so I'm giving you a trivial example. I don't even know if it would be applicable to us. I've worked with enough information scientists and librarians that I know that if you try to do it and they don't feel like you know what you're doing, you get yelled at. But you can do if you're reasonably certain of your hierarchies, you can model them really, really easily in Solr. A little bit more about the faceting. Obviously, not our site because we don't let you search for boots. This is Zappos. For those that don't know, Zappos, now owned by Amazon, is a shoe site. I think they've really nailed the fast, and I believe they use Solr. I think they've nailed the guided search through fasting really, really well, and I keep pushing our people to think about this. So I just looked for boots, or actually I believe I just typed in shoes, and so it came back. Here's all the styles and how many of each. And of course, if you click on those, it appends it to the query, allowing the guide to search further. I think this would be really key to what we do. I think this is key. I think this is something that everyone in the search field needs to think about when they are dealing with anybody other than expert users. And even then, expert users that have easier tools may get to spend their time on their expertise instead of building queries. So that's about it for me. Obligatory information. Follow me on Twitter and you won't get many updates, I promise. And so we've got some time for questions. How do we analyze the relationship between two individuals? So we don't per se, as from a search perspective. I mean, once you kind of find each other in our site, you're free to communicate and exchange information. And we do care about that, but not really from a search perspective. Other than we want to look at the people that you do engage with, both positively and negatively. And this isn't just like it's not that they just communicated. It's also I hid you or I reported you. These are all strong indicators. Whenever a user does something, it's interesting, right? Users don't actually do any more than they actually have to. So when they do something, it's interesting to watch. So we're looking at that from a lot of different perspectives. Obviously the first one is fraud. We watch if people are always reporting or hiding somebody. We always double check them to make sure it's a real profile. But we're not really modeling any of that stuff in Solr per se. Hi, yes.
Hi. Can you talk a little more about how you model hierarchies in Solr?
So I can, because I just throw that out there. It's, again, not something we're actually doing, something we kind of threw out. And so there's two ways to think about this. You can think about it as a taxonomy, traditional taxonomy hierarchy thing, or a clustering thing. So I work with a lot of machine learning people, and machine learning in the traditional taxonomy space is an interesting battle because the machine learning people are like, oh, taxonomies are useless. They give you false hope. And so they say the real thing is just watch everything and figure out how it really clusters. And I keep pushing back saying, well, I think there's still some value. I think the Library of Congress catalog of terms is still an important thing. So what you can do, and we don't do this, I'm just giving you this as an example, is we have a section called user interests. Like, what do you like to do? And so do I like to watch football, or do I like to play football? Let me expand a little bit on that earlier example. So there are three things, I think, here in this potentially in this hierarchy. There's the active and passive aspects. I like to play or watch. There is sport, and then there's football, that specific sport. So you could say, you could say something like, well, I want to match people that like to watch football, but I also probably want to match people that watch basketball. So if you create a hierarchy of these of passive sport football, passive sport basketball, the people that match all three, the football watchers, are going to go up at the top. The people that match two of these, passive and sport, are going to go below that. So this is just a consideration for us. We've done some prototyping on it, but we haven't put it in front of any users, so we don't have any real good data there. You're all looking at me like I'm the only thing between you and lunch.